Okay, so again, real quick, what's left to cover in the math curriculum, we've kind of already covered in part 2, so we're going to move on from there. Okay, so this presentation is a review to go over the stuff that has not yet been covered, or sorry, that we've already covered, and to just sort of reinforce some stuff that I think some of you might be struggling with, specifically fractions. Okay, so fractions are part of a whole. We use whole numbers when we're talking about things that we count with, but if we think of things in terms of shapes, a fraction is a portion of the whole. So I could divide that into 2 portions. Okay, I could also divide it into 4 portions. So in order to make this usable at the level of mathematics you guys are now approaching, we need to stop talking about shapes and start talking about the language of numbers and mathematics. Okay, so to do this, to write a fraction in the language of mathematics, we use a line and we separate 2 numbers by that line. But here's the way it works. When we divide something up, we're dividing it up into pieces. So for example, if I cut the pizza into 2 pieces, there are 2 parts to that pizza. If I give you one of the parts, one of the 2, then that's the way the fraction is represented. You have one of the 2 parts. If I cut the pizza into 4 parts, and I give you 3 of those pieces of pizza, you have 3 of the 4 parts of that pizza. And that's the way the fraction works. Okay? If you still have all 4 parts, you have 4 of the 4 parts. In other words, you have the whole pizza. That's why 4 over 4 is 1. It's just one whole pizza. Okay? But if you only have 3, then you have 3 of the 4 parts. That's how the fraction is represented. So that's the visualization, but you guys now need to just focus on the fractions as numbers, as fractional numbers. Okay, so let's say this is a chocolate bar. It's divided up into 8 chocolate bar pieces. Okay? You have 3 of those pieces, which means you have 3 of the 8 pieces. As a fraction, you write it as 3 over 8. The way you speak it, there's lots of different ways you can say it. You can say 3/8. You can say 3 over 8. Okay, there's lots of different ways to say the fraction. Just be clear in how you write the fraction. Now, I didn't say this, but you should always assume when you divide something up that it's evenly divided. Okay? Now, fractions can represent anything. So let's say again you have 7 pets. That's a lot of pets, but let's say you have 7 of them. 4 dogs, 2 cats, and 1 hamster. Okay? This means that the dogs make up 4/7 of your pets. 4 of the total 7 pets are dogs. 2 of the total 7 are cats, and 1 of the total 7 amount of pets are hamsters. So fractions can be applied to all kinds of things. Anything, essentially. Numbers represent things, right? When you use numbers, you're using them to represent measurements when you're building a fence, or the number of things you're measuring when you're working on a car engine or something like that. There's tons of different things that fractions can be used for to represent parts of a whole. Okay? So now let's keep going with this language stuff. The top number in math is called the numerator. The bottom number is called the denominator. Okay? Language of mathematics. Fractions that represent the same amount are said to be equivalent fractions. So this fraction here is 1 over 2, or 1/2, and this fraction is 4 out of 8 pieces, or 4/8. But if you notice the section that's colored, it's the same amount. So those 2 fractions essentially are equal. They are equivalent. If I was giving you this, if we were cutting up a cake, and I said, do you want this big piece, or do you want these 4 smaller pieces, you'd go, doesn't matter. Why? Because you get the same amount of cake. Okay? All right. Now this is important, because now if we have these equivalent fractions, we can combine them easily, especially if the denominators are the same. So here I'm going to try and go 3 over 8 and 4 over 8. I'm going to combine them. So here's the picture. This is 3 over 8, and this is 4 over 8. Because they're the same, I can just take that piece and combine them, And now what you see I have here is 7 out of 8 pieces, which kind of shows you when you add fractions together, that's why the denominator stays the same, because we still have the same number of pieces. Yes?
There's an error in there. You have 4 parts in the 9.
What?
4 parts in the 9, right after, like...
Oh, you're right. Yes, I'm sorry. Yeah, I'll fix that. Okay? Thank you for pointing that out. Okay, so let's stop looking at pictures and examples. Let's just come up with a method. Okay, let's come up with a recipe. So basically, if the denominators are the same, doesn't matter what the number is, just add the numerators. And it works the same with subtraction. So as long as the denominators are the same, you can add the numerators or you can subtract the numerators. The denominator will stay the same. That's going to be important later. Okay? Now fractions are just a division problem. Okay? So if you see 12 divided by 6, you could also write it this way. Maybe this was the first way you learned about division. But as well, we're talking about that as a fraction, 12 over 6. That means the same thing. So always keep that in mind, that fractions and division are essentially the same way, and that's how we can convert. If we want to convert any fraction into a decimal, as you'll see later, you just do the division. You just perform the division. Okay? That's also, by the way, why you can never have a denominator of 0, because you can never divide by 0, and that's because you can never have something divided into 0 parts. It just doesn't make sense logically. Okay, so when we're speaking about decimal numbers, we can analyze it as that. We can say, well, we can actually just perform the division, especially if we have a calculator, and come up with a decimal. Super, super easy. But when we go the other way, when we convert decimals into fractions, with that it's a little bit harder. Now you have to think of it in its place order. So really when you're talking about the decimal portion, the .6 really means 6 over 10. The 4 means 4 over 100. And the 5 means 5 over 1,000. So really this is 645 over 1,000. Okay? Or there's a couple other examples over here. That's a little trickier. Takes a little practice, but that's how it works. Okay? Sometimes when you convert from fractions to decimals, you get those repeating numbers that just go on forever. Okay? That will happen. Fractions and decimals don't always work out evenly quite that way. Okay? Now, if when we're looking at two fractions, the denominators are different, then we need to again come up with that idea of a common denominator. In other words, the denominators are both the same in both fractions. Okay? To do this, we need to create an equivalent fraction. We need to find a way to make them both have the same denominator. Okay? The easiest way to do this, not the only way, but the easiest way is to just multiply the two numbers together. So here we have 1 over 3 and 2 over 5. What's the common denominator? I'm not going to overthink this, what the common denominator between 3 and 5 is. I'm just going to multiply them together. So I know the common denominator is going to be 15. But what's the numerator? Well, the numerator you create by whatever number you multiplied the denominator by to get 15, you do the same with the numerator. Okay? There's actually an error in this. Before anyone points it out, there's a little error in this one. So this right here should be a 5. Okay? So this should be a 5 over 15. Okay, so my apologies. I'll actually fix that and update that, but for now, it's there. Once they have the common denominator, okay, then I can compare them. So I can see, are they greater than, are they less than, or are they equal or equivalent? As well, once I have a common denominator, as I said before, now I can do addition. Now I can do subtraction. So let's just try one. 2 over 3 plus 3 over 5. I need a common denominator. Okay? So 2 over 3, 3 over 5, I'm not going to overthink it. I'm just going to use 15. So 3 times 5, 2 times 5, 10 over 15. And rather than 3 over 5, I say 5 times 3, 3 times 3, 9 over 15. Now I can add them. Now I've got 10 over 15 and 9 over 15. Now I can add them. 10 plus 9, 19 over 15. So I'm good. I'm done. But I couldn't do that addition unless I had the common denominator. And one of the reasons, again, I'm presenting this to you guys is so you have this for notes, so you can remember how to do this. Okay? For some of you, you might want to go a little more advanced. There's this idea of not the most easiest common denominator, but the lowest common denominator. I'm not going to go into that one right now. Now, that's harder than multiplication and division. Multiplication and division with fractions is actually way easier. To multiply, all you got to do is multiply the two numerators and multiply the two denominators. So here you can see 3 over 4 times 2 over 3 is just 3 times 2, 4 times 3, 6 over 12, you're done. With division, it's also simple, but there's one extra step. You turn division into multiplication by just flipping the second fraction. So here you can see the the second fraction is 2 over 3. All I do is flip that to be 3 over 2, and division turns into multiplication, and then I just multiply the top and I multiply the bottom. So I think those two are really easy to do. The other thing you can do with fractions is what's called simplify the fractions. I haven't really asked you to do that on any of the assignments yet, but a lot of you asked me about that. Simplification basically just means rewriting the fraction as an equivalent fraction. These two fractions, as we've shown before, are equivalent. They're the same. This is 1 over 2. This is 4 over 8. So they mean the same thing. So it would be nicer to write 4 over 8 as a simpler fraction. Okay? The method for doing this, sometimes you call this reducing, is to find a value you can evenly divide into both fractions, numerator and denominator, okay, into both halves. Okay? So in this case, 4 over 8, you can divide them both by 4. 4 divided by 4 is 1, 8 divided by 4 is 2. Another way that's a little more complicated that I'm not showing here is called factoring, okay, which is something that will continue in the course, and especially for those of you going into next math, say the pre-cal or the applied, factoring will be a bigger part of your day, but I don't want to get into that right now. Okay. Now, some fractions have a larger numerator than a denominator, like this. This is called an improper fraction, okay? Now, in here I describe how to deal with this. There's also something called mixed numbers, which you have a whole number portion and a fractional portion together. So I created a little animation to kind of show you, and I did this on the board yesterday. Here I describe the process of converting mixed numbers, and then also I then describe it. So here's the animation. I thought this was a little bit easier to understand. So you're given this mixed number. The way to convert it, this number multiplies by this number. Then, so 6 times 3, 18. Then take that value and add it to the numerator. So 18 plus 2, 20. That number, 20, is then used as the new numerator. The denominator stays the same, doesn't change. It's the original denominator. Okay? So I thought this was a kind of a better way to look at it. Now, same with going the other way, okay, to convert an improper fraction into a mixed number. So I describe it here, but let me show you the way I animated it for you guys, okay? So here's our improper fraction. The way to convert this is I turned that into a division problem, as you've seen before, okay? Okay? So now I'm going to divide it. Now here I can go old school division system. 5 or 32 divided by 5. So I can rewrite it and perform the division. So like you would do here. When you get to this part, stop. Stop at the remainder. You may remember remainders from back in the day. Okay? The remainder is useful to you. Because what you do is the answer you got, the 6, becomes the whole number. And the remainder becomes the new numerator over the original denominator. Okay? That's how you perform that operation if you need to. So there's two diagrams here on how to convert mixed numbers into improper fractions, and if we went back, how to convert improper fractions into mixed numbers. So you can go back and forth that way. I've already shown you how you can convert fractions into decimals and decimals into fractions. So now you have the ability, hopefully if you study and practice, to convert all these different rational number types into other types Types that maybe are easier to use, easier to work with. Okay, that's my stuff about fractions. Let's wrap today by looking at the unit so far, okay? This is what your math curriculum says. This is what you will be tested on, absolutely, in your unit test and in your final exam. These are the 3 points that the Manitoba curriculum says you need to know to pass grade 9 math, okay? I'm not going to read them to you. I've already read them to you before. But just know those are the 3. Let's break it down further. Let's just say, I'm just going to break down the important things to know in this unit. You need to know rational numbers, fractions, decimals, what a number line is, powers, and actually number 5 you can actually strike if you want. You actually don't need to know powers. Square roots and perfect and non-perfect squares. And as I've shown you in the assignment, this is how they break down. What do you need to know about rational numbers? What do you really need to know about fractions? What do you really need to know about decimals? What do you really need to know about number lines? What do you need to know about powers? And notice what it says there under powers. It says nothing. Just be aware of what they are. We're going to cover them in the next unit. Okay? And square roots, what you need to know. Now, the reason I went so quickly through this is also on your assignment. So it's something for you guys to work through tomorrow. Okay? We're almost out of time. But my apologies for restarting that